Today we're going to be talking about some special quadrilaterals. And just as a review, a parallelogram is a quadrilateral with two pairs of parallel sides. Remember, that's the definition. And then each one of these is a property of a parallelogram. So the diagonals bisect each other, opposite sides are congruent, and opposite angles are congruent. So another special quadrilateral is a rectangle. And a rectangle is a quadrilateral with four right angles. So this is the definition of a rectangle. So if you want to prove something's a rectangle, you have to use this definition or another theorem that we're going to talk about in a minute. Now each one of these is a property of a rectangle, which is it has all the properties of a parallelogram. Now why is that? Because it's a quadrilateral with four right angles. So right angle, right angle, right angle, right angle. So you now know that the opposite angles are congruent, which makes it a parallelogram, which makes the opposite sides congruent. The diagonals bisect each other, so when I draw in these diagonals, they bisect one another. But also another additional property of a rectangle is the diagonals are congruent. Because if you look at it like this, you have this triangle up here. That triangle there is going to be congruent to the bottom triangle by side angle side. So thus, the diagonals are going to be congruent. Rhombus, a rectangle with four congruent sides. Okay, so again, this is the definition of a rhombus. If you want to prove something is a rhombus, you need to use this definition, four congruent sides. Okay, so if I have four congruent sides, that means I am also a parallelogram because my opposite sides are congruent, which means the diagonals bisect each other. But also the diagonals are perpendicular. So here our diagonals are perpendicular, and then the diagonals bisects the angles, which means this angle there is congruent to that angle there. Since opposite angles are congruent, this angle here is also equal to that angle there. This angle here is congruent to that angle there, and then the opposite angles are also congruent. So you have all those congruent angles. But notice, 1 and 2, the angles, those angles are complementary because I have a right triangle. Okay, a square. A square is a quadrilateral with four right angles. So I have, and again, this is definition of a square. And four congruent sides. So four congruent sides, four right angles. Now, this is the most exclusive of all of our special quadrilaterals because it has all the properties of a parallelogram. Opposite sides equal, opposite angles equal, diagonals are going to bisect each other, but also it has the same properties as a rectangle. Well, that means the diagonals are congruent, and also a rhombus, which also means that our diagonals are perpendicular. So this has all the properties of each one of our special quadrilaterals. Okay, now here are two additional theorems that we could prove, and I'll talk about how we could prove them if we wanted to about special quadrilaterals. So the first one, if an angle in a parallelogram. So I know this figure here is a parallelogram. So I know we have a parallelogram, which means opposite angles congruent, opposite sides congruent. If one of these is a right angle, then the parallelogram is a rectangle. Well, let's think about this. Since we know it's a parallelogram, we know opposite angles are equal. So I know this angle here is congruent to that angle down there. Now we know since I'm parallel, the consecutive angles are supplementary, so I have a right angle there, then by definition of a rectangle, we have four right angles, which makes our figure a rectangle. Okay, so this is an additional way that I can prove a figure, specifically if it's a parallelogram, is a rectangle. Now, consecutive sides. If consecutive sides of a parallelogram are congruent, which means two sides right next to each other are congruent. Now again, remember, this is of a parallelogram, then our parallelogram is a rhombus. Well, we know this figure down here is already a parallelogram, so I know the opposite sides are congruent. So I can mark my congruent pieces. So now I have four sides that are all congruent. By definition of a rhombus, we know our figure is now a rhombus. Okay, this is an important theorem. Please make sure that you understand this theorem. Okay, the midpoint of the hypotenuse of a right triangle. So I have a right triangle. M is the midpoint of our hypotenuse. It is equidistant from the three vertices, meaning that length there is equal to that length there is equal to that length there. So XM is congruent to MY, which is congruent to ZM. And we can prove that if I were to draw a figure here, extend those sides so that I have a right angle, and then I would have a rectangle. We could go through that proof, but I choose not to go through that proof in this section. Okay, give it a right triangle where BM is the median. Remember, the median goes from a vertex to the midpoint of the opposite side. So AM is equal to MC. Well, from the last theorem, we know that M is the midpoint, so therefore BM is also equal to both AM and MC. BM is 3x minus 5. AC, the whole thing, is 4x plus 4. So that means that MC is equal to half of that, which is 2x plus 2. MC is equal to BM. So 2x plus 2 is equal to 3x minus 5. If I subtract the 2x over, I get x. If I add the 5 over, we get 8. I needed to solve for x, and x equals 8 then. Okay, prove the statement. If the diagonals of a parallelogram are perpendicular, so I know I have a parallelogram ABCD, then the parallelogram is a rhombus. Remember, we have to use either the definition or that theorem that we chose. I'm going to name the intersection of those x. We always start out with our given. Parallelogram ABCD, and AC is perpendicular to BD. And we are given that. Second step. Okay. So I'd either need to prove that all the sides are equal, or since we already know it's a parallelogram, if I prove two consecutive sides congruent, then I know we're going to have a rhombus. So let's see how I could prove AB equal to AD. Well, we know AX or AC is perpendicular to BD. So angle 1, and let me name this angle over here 2, are going to be right angles, and let me remove that marking. So angle 1 equals 90, and angle 2 equals 90 by definition of perpendicular lines. So then I know angle 1 is congruent to angle 2 by substitution. I know AX is equal to itself. That's reflexive. Okay, fifth step now. If I could get bx equal to xd, that would be helpful. We know since ABCD is a parallelogram that AC and BD bisect each other. So AC and BD bisect each other. And that's because a parallelogram diagonals bisect. Okay, step 6. Since the diagonals bisect each other, I have to say x is the midpoint of BD. Definition of a bisector so since x is the midpoint, then I can say finally bx is equal to xd, and that is by definition of a midpoint. Okay, now that I know those two adjacent triangles, triangle ABX is congruent to triangle ADX by side angle side. Now I can say AB is congruent to AD by CPCTC. Now our last step. ABCD is a rhombus. Because if you have consecutive sides, sides of a parallelogram congruent gives us a rhombus. Okay, so I used that theorem. If I wanted to, I could have proved all of the triangles congruent and said then thus all the sides were congruent. But remember to work smarter. We have a theorem that says if the consecutive sides of a parallelogram are congruent, that's going to give us a rhombus. Okay, there are your lesson questions for the day. Please make sure those are submitted on time.